Okay, ladies and gentlemen, today we're going to be talking a little bit about mole calculations, and we're going to add a little piece to this. So we're going to talk about the two other factors that are involved here. So you're really familiar with this because we just lectured about this and we just talked about this in the last couple of days. So representative particles are 2.0 times 10 to the 23rd particles for every 1 mole. And of course, the molar mass is the atomic mass from the periodic table. You add up, you count all of the atoms, you multiply by the mass of each atom, and you add all that together, and you get the molar mass, and that is equal to 1 mole. But now we're going to add two other relationships. One relationship is for gases only, and it is liters of gas. And so what we have is we have 22.4 liters of gas at something called STP. STP is standard temperature and pressure. Officially, that is 25 degrees Celsius and 1 atmosphere. No, it's 0 degrees Celsius and 1 atmosphere. I'm sorry. STP for gases is 0 degrees Celsius and 1 atmosphere. So this is very specific, and each problem that you'll be doing, you're going to be assuming STP because you don't know anything else yet. When and if you take AP, we'll get into gas laws and we'll be able to change those selections. But we're always going to start here at STP. STP is always going to be our starting point, and then we're going to move from there. But it's 22.4 liters. So this one is very similar to the 6.02 because they have the same relationship. There are 6.02 times 10 to the 23rd particles. There are 22.4 liters in 1 mole of gas at STP. So those relationships, these relationships on either side of the mole heart to the left and the right, are actually always going to be the same. The one on the top and the bottom are not always the same. They change. So the one on the top is, oh, I'm sorry, I'm going backwards. Sorry about that. Is liters of solution. So if we're talking about liters of solution, we want to find out how many liters of solution. We're given liters of solution. We need something called molarity. What molarity does is molarity basically talks to us about moles per liter. The unit is given as a big M. That's molarity. So when you see a big M, you have moles per liter. Now, the difference in this is that you're not always going to see 1 mole. As a matter of fact, if you have a molarity of 6 molar, that's going to be considered 6 moles in 1 liter of solution. So this is talking about when we take a solid and we dissolve it into solution, we get a molarity. And we usually do this with ionic solids, and this is where we're going to see this most often. So whenever you see anything that has a big M, that's moles per liter. And we can use that in a conversion factor, okay? So these are the two that we're going to be adding to this. So let's look at converting volume to moles. So how many moles of hydrogen are in 100 liters of hydrogen at STP? Well, what are we given? We're given 100 liters. I'm sorry, that shouldn't have come up first. 100 liters are our given. What are we finding? We're finding the number of moles. So here we have our conversion bar. Liters go on the bottom. Why? We still want to cancel out liters, okay? Moles go on the top because we still want to find moles. 22.4 liters goes on the bottom because it's always 22.4, and since we're at STP right there, we know we're going to use 22.4, and then 1 goes with moles. What unit cancels out? That's right, liters cancel out. It's gone. So now it's 100 times 1 divided by 22.4, and we get an answer of 4.64. 4.64, okay? So this is pretty simple. It's very similar. We're using 22.4 every single time. I'm not going to give you any problems where you wouldn't use 22.4. Always look for STP or assume STP because you don't know enough to be able to do anything else right at this moment. So let's go the other way. Moles to volume. How many liters are occupied by 3 moles of oxygen gas at STP? So I know I have 3 moles of gas. So there are 3 moles of oxygen gas. What am I looking for? I'm looking for the number of liters of oxygen gas. How do I do that? Well, I have to do the conversion bar. What goes on the bottom? What are we trying to get rid of? We're trying to get rid of moles. What are we trying to find? We're trying to find liters. How many moles are there? There's 1 mole. How many liters are there? 22.4. What unit cancels out? Yeah, moles cancel out. Okay, so now we have 3 times 22.4 divided by 1, and we get 67.2 liters. Okay, and that's liters of oxygen. I didn't do a very good job of writing the substance down, but you need to do a better job, and I will change that for future dates, okay? So the next one is a little harder. When we're working with molarity, we have a little bit more to do. So how many moles of hydrochloric acid are in 125 milliliters of 4 molar hydrochloric acid? And you're going to say, Mrs. Rains, I'm given two things. I have two numbers there. What do I do? Well, first of all, when you see that big M, that big N stands for moles per liter. When you see 4M, that's your conversion factor. So don't use that. You're going to use the other piece that you're given. And what other piece are you given? You're given 125 milliliters. So that's our given. And we have to change it to liters because molarity is moles per liter. How do we do that? Well, we take 125. We know we have kings, have dungeons, under, dark, castle, moats. I'm at milli. And I want to go to my liters. So I'm going 1, 2, 3 places. So I take my decimal point 1, 2, 3 places and I get 1.25 liters. So we have to go back to our conversion of the metric system. What are we looking for? We're looking for a number of moles of hydrochloric acid. Okay? Now, conversion bar. Now this is where it gets a little hairy because this thing right here, the 4 molar, tells us that we have moles per liter. So we have to be really careful how we put it in here. We still have to put things in so we get rid of what we need to get rid of and we keep what we need to keep. So we know we're trying to get rid of what? We're trying to get rid of liters. So liters are going to go on the bottom. What are we trying to get? We're trying to get moles. So in this case, it's pretty simple. We have 1 liter and 4 moles because this 4 molar says there are 4 moles in 1 liter. Okay, that's what we get. And so that's what we put it in. So the number always goes with moles. So unlike what we've done before where moles are always 1, and when we're using molarity, the number that's represented in the molar always goes with moles and there's always just 1 liter. And so that's a little change. So liters cancel out. So we have 1.25 times 4 and we get 0.500 moles. That's how many moles of hydrochloric acid are in that many milliliters of hydrochloric acid if it's 4 molar. Okay, so that's really important when we're doing some other calculations later on because we use a lot of solutions and that's going to come in handy for us. Okay, so converting moles to volume using molarity. Okay, how many milliliters of NaOH would you need to use to have 3.45 moles of NaOH if you had a 0.65 molar solution of NaOH? So again, this is going to be used in the conversion factor. We don't use it right now. So what else are we given? We're given 4.35 moles of NaOH. So that's where we're going to start. What are we looking for? We're looking for milliliters. I'm going to start here with liters and then I'm going to convert to milliliters in just a minute. Okay, so I'll show you that in just a second. So conversion bars say, okay, here I go. I need to get rid of moles. Why? Because moles are my givens. So I need to put moles on the bottom. What do I need to put on the top? I need to put liters on the bottom. And this is where it gets a little wacky because we always usually put 1 for mole. But because molarity is moles per liter, the 0.65 goes with the mole. What number goes with liter? 1. What unit cancels out? Yeah, the mole cancels out. So we have 3.45 times 1 divided by 6.5, or 0.65, I'm sorry, 0.65, and we get 5.31 liters. But we're not done there because our problem asked for how many milliliters we have. So I need to convert liters to milliliters. I have 5.31 liters. Again, remember, kings have dungeons, under, dark, castle, moats. I'm going from my SI unit to milli. So I'm going to go 1, 2, 3 places in that direction. So you will notice I'm going 1 place, 2 places, 3 places. Remember, I have to fill this place with a 0. So I get 5,310 milliliters. And that's the right number of significant figures because I don't have a decimal point there and I have 3 significant figures there. So really, it's not very hard. Calculating with mole conversions is really not difficult. You just have to take it 1 step at a time, figure out what you're given, what you're trying to find, and make a pathway. Okay? All right, thank you very much.